Okay, so welcome and good day, class. So this is our first session for our subject, Computer Softwares in Structural Analysis. So today we are going to cover the introduction. Ano ba yung grasp? Okay, so it was mentioned in your syllabus na ito yung gagamitin natin as one of the software for 2D analysis. And then for the 3D, we will use STAAD Pro. Okay, so and then by and by we are going to practice graphs modeling. So we will go over with the process and the workflow in modeling the structure using graphs, and eventually we're going to analyze that model. Okay, so as for our learning objectives, at the end of the session you will be able to i-describe nyo ano ba yung sino bang nag-develop ng graphs, when was it developed, okay, and then how graphs has evolved into a more complex software. Secondly, as I have said, we will go over with the process, the workflow, and there are things to do for your practice. So you're gonna learn how to construct structural models in graphs. So anyway, the abbreviation GRASP stands for Graphical Rapid Analysis of Structures Program. So this is a special purpose finite element package for the analysis of plane trusses and frames. So ang developer nito is the ASICOMS. So yung ASICOMS stands for Asian Center for Engineering Computations and Software. So this is part of the Asian Institute of Technology in Thailand. Okay. So ASICOMS was established in 1995 as one of the first centers of excellence at the Asian Institute of Technology. So it aims to provide an impetus to the research in engineering computations, the development of quality computer software tools for engineering applications, and training on their effective use. Well, later on you will explore that GRASP is a basic 2D analysis, but ganun siya ka-powerful in terms of simplification of structural analysis. Well, we have learned a lot of procedures in coming up with structural analysis, like the moment distribution method, what else? Integration method, the area moment method, the tree equation method, and other methods like approximate method, portal, and cantilever method. So, nakita nyo naman kung gaano kahaba and tedious the process using hand calculations and calculator. Ano? So, medyo matagal at medyo mabusisi. So, it is also prone to errors because of the tediousness of the process. So, itong ASICOMS, sila lang naman yung nag-develop ng mga sikat na software ngayon. Because, yun nga, 1995 pa yan. They have already established reliable softwares for structural engineering, like we have here the CSI bridge, the CSI column, the SAFE, Perform 3D, SAP 2000, and then ETABS. You can find all of this software in publications, some that were related to structural engineering. Okay, so before we are going to start with the procedure and workflow process, let us have a review on the role of the structural analysis. Well, basically, this we need to have a structural analysis to have a basis, ano, to come up with a sound structural design that is compliant to safety and serviceability requirement of the structural code. So, may mga requirement ng structural code, like ano ba yung dapat na sizes, the minimum size and thickness of a structural element if you are designing an SMRF or seismic moment resisting frame. Okay, you need to comply with those. Well, of course, in your model, it's not a one-time model, ano, na kapag minodel mo na, yun na yun. You can see here, on the 3 stages of structural design, that on the modeling and analysis, you need to have a trial sections, okay, in your modeling. Well, this modeling and analysis was based on the conceptual design. So this is the very first stage, the conceptual design. You need to comply with the requirements of your client in terms of the function of the building. So if the function of a building should require library facilities, sports facilities, hardware facilities, and many others, you need to take note on that function, ano, or on that aspect, ano, dapat may incorporate mo yun sa architectural functional plans. So later on with your requirement, you need to indicate the functions, okay, and the circulation of your building in terms of architectural, okay, because architectural should be the basis on your structural system, ano. If your function should be, halimbawa, ano, parking, okay, parking building or a centralized parking building, of course, yung structural system would require a larger and a longer structural element like beams, ano. So, lalaki yung section mo kung gusto mong mag-function siya ng mas mabigat or heavier loading and a longer span. Okay? So, with that structural system, punta ka na sa trial section. Of course, yung trial section, hindi ka naman manghuhula ng mga section mo. Of course, yeah, you need to base your trial sections on the requirements of the National Code of the Philippines or the National Structural Code of the Philippines. Like, for example, minimum thickness, okay? So, yung mga ganon. So, from that, the real system will be derived and converted to idealized. Okay, the term idealized was introduced in your structural theory, no? When we say structural or idealized structure, ito yung representation ng real system. Okay? And then, from that, i-analyze mo na. And then from analysis, you will obtain design basis like the rotation, the displacement, okay, or the response of the structure to your loading or excitation, no? So, ano ba yung excitation? When you load the structure, what will be the effect? Okay? What will be the effect to the structure? Whether your loading is a lateral one, when we say a lateral loading, it is the effect of the wind and the earthquake. And a vertical loading, pwede yung dead load tsaka live load. And then, okay, so you will derive the member. So, kung pwede naman, kung acceptable naman yung member, hindi mo na kailangang mag-enlarge ng section. Kasi nga, halimbawa, nag-assume ka ng section that is limited. Kasi yung isang section, it would have its limit on reinforcement, especially if you are designing it on reinforced concrete. So, sasabihin naman ng analysis mo, it is not suitable, or yung section mo, it has reached the maximum reinforcement, and it cannot resist the required serviceability. Okay, so that is the time you are going to revise the section. So what you will do is to enlarge that section if necessary. Okay, but if it is not acceptable naman, ayun, dito ka na sa detailing mo, sa connection design if you are in steel design. Okay, so dito mo na i-details, and then that should end your design. Okay, so this is the design process. So this is the analytical model of the structure. So as we have said, it is the simplified representation of the real structure. So as much as possible, it should represent the real system. Okay, so the real system, you can see here, dito sa picture to, this is a continuous bridge, you know. So in your structural analysis, you have learned that this is the idealized system, ano? So continuous beam, it is supported by a pin connection yan per span. And then the structural model will have its loading, the vibration, settlement, the thermal changes. And then from that, it should have a response. So the response will be having stresses, strains, displacement, support reactions, and stress resultants. So, ito yung magiging basis natin in our design later on. So, there are various ways of modeling a structure. So, if you want to model it in a solid way, you can do it. And then, if you want to have it in a 3D plate frame or the finite element method, you can have letter C, and then the 3D frame, you can model it in a 3D frame, pero mas mahirap gawin yan by hand calculations, no? And letter E, 2D frame. So itong 2D frame, ito yung gagawin natin with this grasp software. So ito 2D, two-dimensional. Okay, so if we intend to have it in 3D, mas ma-emphasize natin yung effect ng torsion, especially in lateral movement. Okay, so kapag lateral movement, ito kasi mga frame niya to, it will be subject to torsional stresses. But in 2D, that could be neglected, or yun, there's no way we can emphasize the effect of torsion in 2D frames. Okay, but we can still derive the effects of lateral movement of earthquakes and wind load, as well as the gravity loads, which are the dead load and live load. Okay, so it's important that you know the supports. Of course, we have already learned a lot of supports and discuss it in your structural theory, no? Meron tayong roller, a pin connection, fixed or rigid, flexible. E paano naman, sir, pag sa building, ano? Which lies on soil. Okay, so importante dito yung model mo, no? You can assume it to be fixed or rigid kung yung design mo is a rough foundation. Ano yung rough foundation? This is a matte foundation. Meaning, lahat ng poste mo, iisa lang yung pundasyon. So, a matte foundation, isang pundasyon on all columns. You can assume it to be fixed or rigid. Another one, you can assume it to be fixed or rigid kung yung pundasyon mo is supported by stiff pile, ano? Kapag may pilote ka dun sa pundasyon, you can assume it to be fixed or rigid because yun nga, pag lumindol, naka-fix siya, naka-attach siya dun sa hard strata ng supporting soil. Okay? And then, you can assume it to be fixed or rigid if your foundation is a hard strata. Okay? So, for pin naman, ano, kapag yung foundation mo is a dense soil wherein it is subjected to a deformation, ano, you may assume it to be pin connection, especially if your foundation is a square footing, ano, meaning hindi nagko-combine sa ibang column yung footing. So, isang footing for one column. So that is a square footing or spread footing, should say. So that is assumed to be pin connected. Okay, especially when your foundation soil is stiff soil or loose. Okay, stiff soil or loose. Pwede yung pin connection. And then if you wanted to emphasize the SSI or the soil structure interaction between the foundation and the soil, you may use spring models, ano? Kasi yung may mga geotechnical investigation that considers the modulus of subgrade. Yun yung tinatawag na K, ano? So remember, yung spring model, magkakaroon tayo ng K value doon. Okay? So at any rate, those are being included in your model. So it depends on your engineering judgment on what type of support reaction you should place there. Okay. So part of the model is of course the loading. Okay. So I think this was already discussed in your structural theory. Meron tayong dead load, live load, wind load, earthquake loads, and other environmental load like changes in temperature, settlement of the foundation, vehicle loads, hydrostatic forces, soil pressure. Okay? So, itong updated na load combination in our 2015 NSCP. So, this includes dead load, and then fluids, lateral pressure of soil and water, live load, roof live load, ponding load, rain load, and then self-straining force and effects arising from contraction or expansion. Ito yung temperature change, ano? And then W load due to wind pressure. So F1 is equal to 1 for floors and places of public assembly for live loads in excess of 4.8 kilopascal and for garage live load. So you can find that in your NSCP section 203 3.1. Okay, so let us try this example. So let us have an frame with different height, different bay length, loaded as shown, with W dead load 15 kilonewton meter, W live load 7 kilonewton meter. So this is a two-story frame with wind load, of course, 6 kilonewton and 10 kilonewton. So with respect to the dimension, ito yung dimension yan. 343, and then the first floor height is 4 and 3 meters. So we're gonna follow that cross-section of the column and the beam. Itong beam, it is assumed to be T-beam. Okay? And then we're gonna input modulus of elasticity of 21, the unit weight 24 kilonewton per cubic meter, with the coefficient of thermal expansion 11 times 10 raised to negative 6 per degrees Celsius. Okay, so let us try this one. So I'm gonna open now my software. Okay, the graphs software.